Okay, so now we're going to talk about atomic mass. Keep in mind, while I'm going over the notes, make sure that you have a calculator handy. You're copying the notes out also, and make sure you are doing the problems along with this. Okay, so atomic mass is the weighted average of masses of an element's isotope. Okay, so you know what an isotope is already, and every time when you look at your periodic table, there are certain elements that have decimal points as far as their average mass goes. So if you can look at your periodic table, and you should have your periodic table right here. If you don't, then make sure you do get it. Okay, so if we're looking at the periodic table, notice that some of the elements here, almost all of the elements here have decimal numbers as far as their mass goes. Well, this is called your average atomic mass. That is because this mass right here takes in consideration all of the isotopes for that particular element. So you've heard of carbon-12, carbon-13, carbon-14. All of those are isotopes of carbon. And eventually when we add all of the percentages with the masses up together for carbon, then you get a final answer, a final mass. This mass here tells you the mass of all the carbon that is present, the percent abundance of that carbon, okay, of carbon element. And that is true for all the elements that are on the periodic table. There are some elements on the periodic table, well, at least in the periodic table that you have in front of you right now, there aren't numbers here. That's because their mass right here, their average atomic mass, is a whole number. These are synthetic elements that are produced in a lab, and the only stable element that exists is that particular isotope. It's not to say that other isotopes aren't there, it's just that they're not stable. So if only one isotope of each one of these elements exists, then you are going to have a whole number for your average atomic mass. Okay, so going back to your notes, we're looking at, so we're going to go back and say this average is calculated by using both the mass number of the isotopes and the percent composition. So this is the equation that we look at when we're calculating the atomic mass. Notice right here, this is percent of composition of isotope 1, of whichever element you are looking at, okay? So technically, this is really, because it's dividing by 100, this is a ratio that we are looking at. And we can take this ratio and multiply it by the mass of isotope 1. So this is all for isotope 1, and then we can add this up to the percent composition of isotope 2 divided by 100. This is also a ratio that we have. Okay, and this is the mass of the isotope 2. And this is just an equation. Of course, you can have third, fourth, fifth isotope of that same element. Okay, so let's do our first practice problem. It says here, what is the average atomic mass of magnesium if 78.99% has a mass of 23.985 AMU? 10% has a mass of 24.986 AMU, and 11.01% has a mass of 25.983 AMU. Okay, so this is a simple problem. We're just looking for the average atomic mass. So we're going to use this equation right here. So in the equation, we are going to set everything up. This is the ratio times 100. Well, that's what percentages are. Percentages can be written as a ratio times 100. If you divide this percentage by 100, then you're going to get the decimal point. And the decimal point for this would be 0.789. Okay, so this is the ratio that goes over here. And then it says the mass of isotope 1. In this case, we are looking for magnesium, so I'm going to write magnesium. Okay, so the mass of the isotope, that would be 23.985. And we're going to write AMU. Percentage, the unit for percentage is always percentage, and you guys know that. And then I have a second isotope, so 10%, I'm going to convert that into ratios. So that'll be 0.1000, and then 24.986 AMU. Okay, and then of course I have a third isotope for this, so I'm going to write the third isotope. That'll be 0.1101, and the mass is 25.983 AMU. Okay, so we're going to add all of this up in our calculator. So here's my calculator. And since I'm doing 1, 2, 3 different sets, I'm going to use parentheses to help me out. So I'm going to open up a parentheses. So 0.7899, 23.985, and you guys can do this also, and you can just look up once you get your answer. Okay, so our answer in this case, when you add everything up, so before I tell you what the answer is, well, I just want you to know that what I did in my calculator is that I took each one of these quantities and put it in parentheses, and then press the add button and then put the rest in parentheses. Okay, so our answer for this problem is 24.305 AMU. Okay. And don't forget to box in your answer. Okay. So the second problem that you have is the atomic mass of gallium is 69.72 AMU. The masses of the isotopes are 68.9257 AMU and 70.9249 AMU. What is the percent abundance of each isotope? So in this case, we're going to be looking at, we have two different gallium isotopes. We have isotope 1 and isotope 2 of gallium. So I'm going to write over here real quick to help you guys understand what is going on with the gallium. So we have gallium. Okay, the first isotope for gallium, I'm going to move it up, has a mass of about 68.9252, so about 68, 69. So I'm going to make this gallium 69. Okay. Okay. Right here, and the second gallium that we have is gallium 70.9249, so I'm going to make it about 71 gallium. And now what we are looking at is we're looking at the mass of the gallium, and we're looking at the percentage of gallium. Okay, so we're looking at the mass of the first one for the first gallium, which is about 68 right here, 68.9257. And the second gallium, which is about 71, I rounded it off. You know, it's right here. The second gallium is about 70.9249. Now we're looking at the percentage. We'll understand that we are looking at percentages. The total for all percentage is 100. And if I put this in decimal point, then I can even just say 1 because I've put it into decimal point. So right here for the gallium, for the first gallium, I can say that I have added that percentage, I have a certain amount of it, okay? And for the second isotope, well, whatever amount I have, it's going to have to be 100 minus this amount to give me the remaining isotope for the second gallium. So instead of using 100, I'm going to use 1, my decimal number, and it's going to be out of 100. So now I can actually solve this problem using percentages. Okay, so I'm going to take this and I'm going to write it on my paper right here to answer the question. So my total mass, the total atomic mass of my gallium is 69.72 AMUs. So that's going to be 69.72 AMU. I don't need to write AMU, that's my unit. But now what I'm going to do is I'm going to go ahead. This right here is my mass. So if we go back to this equation, this is my mass that I had, and this is my ratio or my percentage. So according to this, I just simply need to multiply these two together, okay? And then I'm going to simply add this to my other, multiplying these two together. So I'm going to add it all up together. So if I go back, I have here, the first one is 10. That's my first ratio or percentage times my mass, which is 68.9257. And then I'm going to add it up again with my second ratio for my second one. And I don't know that. So remember that it is 1 minus x because it's out of 100, the ratio or the percentage, times 70.9249. And you should be able to put this in your calculator, multiply everything together, so you should get 68.9257x. Go ahead and solve this on your own, I'm sure, and then look up when you are finished. Okay. And when you do, you're solving for x now. And that should be 0.627. Okay? That is this is the percentage. We can always switch it to a percentage, and we'll do that in a minute. But we've got this x. We need to find 1 minus x. So I'm going to put it in this problem right here, 1 minus x. And that should be, you're going to substitute this number for x, and that should give me 0.3. Okay. So these are our two ratios. So when we talk about gallium 69, we say that it has a 60.27%. And then when we talk about the second gallium, remember we called it 71. We rounded it off just to make it easy for us. Call this 39.73%. So this tells you, and this should, to check your math, you can always add this together. Because it is percentages, it should always equal, and I'm going to write this in pencil so that you can see it, not in pen, but it should always equal to 100%. Just to check yourself, okay? So just to check yourself, the percentage should always equal to 100. So what this is saying is that 60.27% of gallium exist, has a mass of 68.9257, and 39.73% of the gallium that exists has a mass of 70.9249. When you add everything up together, these two, gallium 69 and 71, should have a total atomic mass of 69.72. So if we go back and look at our periodic table and find gallium, sure enough, gallium has an average atomic mass of 69.72. So we found that, 69.72. That's because 60% of the gallium has this mass, and about 40% of the gallium has a 70 AMU mass. Okay, so I hope this really helped you understand isotopes and average atomic mass. Thank you.